me start the recording. And there we go. When you guys are ready, just go for it.
Wiley or Dan or Kieran?
I'll get started. Thank you everyone for joining. Appreciate you all joining this event. My name is Kiran Ilavankal. I'm an IT architect at AEP. Let's do a quick round of introductions and then we'll get into the meat. Let me start. Again, as I mentioned, I'm an IT architect working on different projects at AEP, focusing on emerging technologies, basically cloud, artificial intelligence, RPA, and things like that. I, along with Dan Lavely, we both help organize the AEP challenge for both the Hack and the Make events. It's a very exciting event for us, a good opportunity to meet all the fresh ideas that come out from you guys. So we are always excited to be part of this. Thank you for that. And so I'd like to pass it on to Dan to introduce himself. Dan, you want to go?
Dan left a comment in chat saying he can't get his microphone to work.
Oh, okay.
It looks like, yeah, Zoom just isn't picking up the microphone, maybe.
Okay, I'll just pass it over to Wiley.
So my name's Wiley Elliott. I'm in our project management group, and I get involved with managing a lot of our innovation projects and some of the non-traditional type stuff. So 2 or 3 years ago, I became aware of Hack and MakeOHI's, and got with some of the IT folks, and we got AEP to become sponsors of the event. So this is our, I think, third Make event that we're actually as a sponsor. And then in previous years, some of us were judges and had a less formal involvement. So we've been learning each year to craft, I think, some better challenges and really work with the students about things they're interested in and that may have some real world implications for us. So thank you.
Thanks, Wiley. We have Jason Parker here. Jason, do you want to go next?
Hi, yes, Jason Parker, and I'm the manager of corporate industrial hygiene, part of the safety and health group for AEP. This is my first time being involved, and I was just kind of asked to come in and provide some, I guess, expertise on some of these challenges.
Thanks, Jason. Adam?
Yeah, get that. Okay. Hey guys, I'm Adam. I'm on the Charge team, so it's kind of one of the R&D groups at AEP. Back in like 2015, I was working with telecom, and then 2019 joined Charge, and I'm currently researching some of our drone capabilities across the different business units. So really looking at what capabilities exist in the industry that we're not utilizing that we could kind of pick up. So yeah, and I'll be one of the judges, but I'll probably just be around a bit through the weekend as well.
Thanks, Adam. So I think that's it from the AEP team. So let me
Karen,
get.
can you hear me now?
Yes, I can. Hey, go ahead, Dan.
Okay, so I'm just gonna. Sorry, I'm going getting the microphone to work there. So I guess I must be in Zoom. So hey, my name's Dan Lilly. I'm a senior project manager at AEP, supporting corporate application development and working alongside Karen on these OSU, MakeOHI, and MakeOHI events.
Did we lose Dan?
He's cutting in and out.
Yeah.
I think we have.
Do you want to briefly review the challenge and then pass it over to Jason for some of the safety background?
Yes, that's what I'm. Yep, thanks. So I wanted to get into the challenge details before handing it over to Jason and the other SMEs. So as you all might have gone through the challenge. So the AEP challenge is to construct a device basically for focusing on worker health and safety monitoring. So basically, as you all know, AEP is involved in a lot of, we have a lot of field employees. We have employees going to different, stations, substations, and all, and visiting places. And, at this time, we are looking for, a device that can help with the safety as well as monitoring, so that when they are near devices and things like that, we have some kind of knowledge on what's going on there. Some examples are like monitoring pulse or blood oxygen, maybe temperature, humidity, and things like that. Ideas for this monitoring device is like these devices can be hooked up to hard hats, which our folks definitely wear when they are on site and in field. Or additionally, other ideas, we are leaving it open so that we are you can think as imaginative as you want. um, Add-on features like text messages and email notifications based on this monitoring will definitely help us quickly get alerts and respond to any situations as needed. So you could typically interface with your phone apps using Bluetooth or some Wi-Fi and try to send these alerts and messages. So in a nutshell, basically a device that monitors employees, while they are away in the field, and kind of send alerts and or email notifications if there is a hazardous situation, or a specific undesirable situation. The challenge document has a list of sensors and other devices that can be utilized for this challenge. So that's in a nutshell. I will now pass it over to Jason, who will kind of kickstart, from a safety perspective, bring that angle out, what safety means to us at AEP, and then other SMEs will chime in with their thoughts on the challenge and address any questions that are there. So passing it over to Jason. Thank you.
Okay. Thank you, Kieran. I was asked to talk a little bit about AEP's safety culture, but then also some of the stuff on particular challenges that we have that relate to these challenges. But at AEP, we always start out with a safety topic before every meeting. So let me just real quickly do one of those first. I thought a perfect one for folks who spend a lot of time walking in a very busy urban area was distracted walking. And I got this information from the National Safety Council. One of the most vulnerable times that we can have is when we're pedestrians in urban areas, because we basically have no protection from all the cars that are around us. Nearly 6,000 pedestrians were struck and killed in motor vehicles 2017, an estimated 7,450 pedestrian deaths total, and that's traffic and non-traffic. So some just basic tips for when you have to be out walking around. Use the sidewalk if possible. If there's no sidewalk, walk facing traffic. Always cross at crosswalks when you can. If there's not a crosswalk or your view is blocked, move to a place where you can see oncoming traffic. Try to make eye contact with drivers who in oncoming vehicles to make sure they see you. Stay off your cell phones. Avoid wearing earbuds when you're out walking around in a busy area, because a lot of times your ears will tell you when something bad is coming your way. Avoid alcohol and drug impairment when you're walking. wear bright reflective clothing or use a flashlight if you have to walk at night. Watch for cars entering or exiting driveways. And then another part of this distracted walking has to do with cell phone use. And I know this is something that that I have to struggle with too. It's not just walking around in the city, it's also just walking around in your house, your apartment, your dorm, wherever you live. Anytime we are walking and we are looking down at that phone, that's an opportunity for us to trip over something, fall downstairs, those kinds of things. So if you have to use your phone while you're out and about, moving around, pause, stop walking, and do what you need to do on your phone. So that's what I have for that. Let me talk a little bit about safety culture at AEP. I introduced myself as a industrial hygiene manager. Many of you, probably most of you, are saying, what the heck is industrial hygiene? I understand that. I get that question all the time. To make it very, very simple, it's just the health side of safety and health. So instead of dealing with things like slips, trips, and falls, I'm typically dealing with things like chemical exposures, noise exposures, any kind of chemical or physical hazards that can affect employees and the public. So I've been at AEP for almost 26 years. And the safety and health culture now is drastically different from what it was 26 years ago. Back then, there was more of an attitude that injuries and illnesses, including some that were serious injuries and illnesses, life-altering events, even fatalities, were just a fact of life. There were just certain events that at that time we thought, hey, we can't prevent these. That attitude has shifted over the years and evolved to a point where we believe that all injuries and illnesses are preventable. And this belief is what we call zero harm. So zero harm is at the heart of everything we do at AEP. It means we believe all occupational illnesses and injuries are preventable because we care that everyone goes home in the same or better condition than when they came to work. So AEP is creating a learning-centric culture where events are looked at objectively and used as an opportunity to prevent further harm. It's a culture that focuses on communicating, learning, and continuously improving so the same events are not repeated. We have a safety philosophy, and that is that no aspect of operations is more important than the health and safety of people. And we have several objectives that guide our work, support that philosophy, and move us towards zero harm. So some of these are create a culture of shared commitment to a safe, healthy, and productive workplace. Involve all employees in an environment of trust, respect, and mutual interest in the personal and economic security provided by a safe and healthy workplace. Fully integrate safety and health into the operations process by designing it first into our facilities and then into our work procedures. Engage employees at all levels using coaching and engagement visits. We believe that management must lead the organization for the culture we want and reinforce those behaviors expected in order to produce a zero harm culture. And accountability for safety and health is owned by each individual performing work for American Electric Power. So that's a little bit on our culture. Just a little bit on some of the specific safety and health challenges that we have that are related to the challenge that we were asking you to look at. So one of our biggest things that we have struggled to get a handle on is hearing loss. At our generation facilities, everything is loud, extremely loud. We've seen our injuries over the years have a nice decline, a nice gradual descent towards zero. But when we look at our hearing losses, it's pretty much remained flat. We've not been able to do that. So I believe one of the challenges was something about monitoring noise levels and possibly being able to communicate to workers when they were in an area that was 85 decibels or something like that. Another big challenge we have is lone workers. And we have a lot of different situations where we ask our employees to work by themselves. And that could be, in a dark basement in a power plant. That could be out walking some transmission line in the middle of nowhere in Texas. And that employee may be out for hours and hours without any communication from coworkers, supervisors, whatever. So one of the things that we were exploring, and there are some products out there that can do this, is some sort of a motion sensor or really a lack of motion sensor that would detect that a person could be injured, incapacitated or something, basically not moving, and be able to send some sort of an alert to someone who could send help for them. Another thing that we continue to struggle with over the years is heat stress. And we've worked with some of our trade organizations to try to find ways to, monitor a worker, do personal monitoring on a worker to determine when they might be going into a heat stress mode. Unfortunately, we haven't been able to find anything that we feel is very good technology. Just monitoring someone's heart rate may not be good enough. Monitoring a skin temperature or something like that probably isn't good enough. What is? And that's still a question that we have out there. And of course, one of the other things that's obviously we're doing all the time is working around energized equipment. And there are some products out there. There's something called a V-Watch that we're giving to our employees that basically, if they're approaching an energized line, it gives them a warning. So I think we were kind of interested in what other kinds of what other things that others might be able to come up with on being able to alert us when we were approaching energized equipment. So I think that is all I had right now. I'll stick around if there's any questions, and Kieran, I'll turn it back over to you.
Thanks, Jason. Any questions for Jason?
I have one real quick. I was
Sure.
wondering, when you guys first adopted the zero harm policy.
The zero harm probably came in about, I'm thinking it was about 7 or 8 years ago. And it's not really even so much, I wouldn't really even call it a policy. It's more of a goal. It's a kind of a journey where we want to go. We recognize there's always going to be incidents, something's always going to go wrong, but the belief is that we can always design layers of protection around people so that there's no lasting harm that comes to them.
Gotcha. Thank you.
Mm-hmm.
Thank you. Good question.
And I'd add a little bit to Jason that, the thinking of that is that it's not just maintaining construction, but we've also worked a lot with our engineering departments. So constructability and, are you designing a system that would require people to be on ladders, or are you leaving access that a bucket truck can get in there? So it's a very in-depth kind of analysis about engineered safeguards, how you're going to maintain it, all those sort of things.
Thanks, Wiley. Any other questions before I hand it over to Joshua? Okay. As mentioned, Jason will be around. So if you have any questions, feel free to jump in. You can use the chat window and ask questions, or feel free to jump in. Thank you. I'd like to now invite Joshua Arlenz. He's a customer design supervisor. He will give us an overview of field work at AEP, so that you can understand a context and the background of how field work is done, which will definitely help in designing the challenge. So welcome, Josh. Thank you.
Thank you. Sorry for joining a little bit late. I had issues hopping on here. For some reason, the link wouldn't work for me, and I had to venture home this afternoon, and my only form of internet at home is through the cell phone. So if I cut in and out or lose video or something, I apologize. Not a whole lot I can do about it. But as Kieran said, my name is Josh Lentz, customer design supervisor out in the Newark district. I started off in customer design as a design technician. And basically what we would do is go meet the customers out in the field and figure out where our facilities are at and what it would take to design a line to get from our existing facilities to that new customer, whether it's commercial, industrial, or a residential customer, and everything in between. So our folks are out in the field regularly meeting with customers. And then on top of that, we're out when a storm blows through and our lines get knocked down. And we're kind of at one of the first people out there out in the front assessing what the damage is and trying to locate where the pockets of damage are at and what materials needed to report back, so that people in the back office that are making decisions understand what materials needed and what type of crews needed to send out that way to get the work done and get power restored. And so they're not having to assess every inch of the line. They can just go focus on and making the repairs and putting the fuse back in or recloser device or whatever it is. In addition to that, we have the line side of work, and those guys are out in the field daily. They're out running bucket trucks and digger trucks and trying to construct what my folks are designing. And when the storms hit, like I talked about, they're the ones that are making the repairs. And I just recently got back from APCO, or Appalachian Power, our sister company from AEP, Ohio, in West Virginia, where we were down there for 18 days from the ice storm that blew through. Hopefully I can do this with my internet limitations, but I was going to share some pictures. We'll see how this works here. Forgive me, I grabbed my wife's laptop when I got home real quick, and it's making me give it permissions to do things. So I might not be able to do this. Yeah, her Mac is wanting me to go do a bunch of privacy and security settings stuff. It doesn't look like it's straightforward. Let me try one more time here. Hopefully I get her password right. Yeah, I might not be able to do it, sorry. But I had a bunch of pictures to kind of show the environment that these folks are working in, particularly down there. So, I mean, we have a pretty diverse environment at AEP. We have everything from, you go up into Indiana, Michigan area and the northern part of Ohio, and everything's flat. I mean, you can just see for miles, and you see wind turbines off on the horizon, and you get a lot of wind and things like that. But everything's fairly accessible, and you don't have any hills. It's funny, when we were down there, they were referring to some of us as flatlanders, because you go down there and everything's a hill. It's kind of wild. I had some pictures of some of the work that was being done. So on the side of a mountain, they had a track digger, and you imagine kind of a small bulldozer, but it looks more like a tank, and it has boom arm on it with an auger on it, and it's designed to be manned, where you can sit in the front and kind of operate it like a dozer. And it's got rack to hold a pole, and so they can try to climb up through streams and rivers and up the side of this hill, but with the rubber tracks, it was slipping in all the mud with everything thawing out that day, and they couldn't get up there with a pole, so they had to use come-alongs and winches and pull the pole up a side of a mountain and hand dig the hole, and then use a series of pulleys and other come-alongs and winches and things to try to stand up in the air and guide it down into the it was quite the sight to see, and it took them a good bit of time to do that. And so there's all kinds of hazards. We talked about slips, trips, and falls and things like that. I mean, just a myriad of things that could have gone wrong, and you're watching them as they pull this pole up in the air. And if one thing kind of went wrong and they weren't paying attention, you're talking about a significant size pole that's hundreds and hundreds of pounds that could come down on somebody. I've known of guys that a pole gets away from and roll down a hill and it hit them in the leg and break their leg in 3 or 4 different places. Just they're massive, a lot of momentum behind them. So they have a lot to contend with, the stressful situations that they're dealing with, as well as the voltage aspect of it. I mean, a lot of our system is 7,200 volts from phase to neutral, or 1247 kV phase to phase, and then we even have some up to like 34,500 phase to phase, or 19.9 kV phase to neutral. So it's nothing to take lightly. And then all of, we just talked about them trying to set that pole and all the hazards that go along with that. I mean, even if they can reach it with a digger truck, you still have a lot of potential energy stored up when they're out there in this environment, and just a lot of things that could go wrong. So I think somebody mentioned the personal voltage detection devices, so that that I know my folks use those when they're out assessing lines, because sometimes you just little conductors hanging down in the trees or whatever, and you might not see it, and it could have a high impedance fault and not trip the fuse or recloser or whatever the protective device is. And so you're walking up on a hot conductor, and that can ruin your day or your life really quickly. I mean, it just cooks you from the inside out, literally. So not anything to take lightly. So there's a lot of hazards there in that field work, a lot of things to consider. And so, like I think Wiley, you were talking about the engineering aspect of it, of trying to build in safety as a component of the engineering piece too. So my folks, they're out there, they're trying to make sure that can they get access to these locations. And while they were replacing lines down in West Virginia, they were trying to maybe reroute some of the lines instead of going up over the hill or the mountain. And where can we maybe relocate this to make these jobs a little bit safer? And a lot of times you're out there and these guys are working in the rain. So it's just all kinds of conditions. It could be really cold out. Hopefully that helps. I was hoping to share some of these images. I think it would paint a little bit better picture, but hopefully that helps and paints a kind of a picture of the conditions these guys are working in. And in addition to that, I mean, the line workers, they're working in rubber gloves. So it could be freezing cold out and you're, 30, 40 foot up in the air with the wind blowing on you. And, or it could be, you could be down in Texas and it could be 110 and you're standing up there with rubber gloves and sleeves on in that kind of condition. And, you got to stop and come down and take breaks frequently and make sure you're hydrated and not overheating, or, get down and get in the truck and get warm because, it's just too cold. The wind's blowing and you're, again, 30, 40 foot up in the air in a bucket with the wind coming right at you. So hopefully that helps paint some of a picture of what the field conditions are like. Anybody have any questions?
Yeah, relating this to the challenge that we've signed for MakeOHI, what kind of safety tech currently exists on technicians' hands? Like at the moment,
the only thing, the only thing they really have is that that we call PVD, personal voltage detection device, and it's something that they wear. They can wear to have a kind of a lanyard around their neck, and it has an isolation case in it so that they can zip it up. So as a lot of times you'll be driving around if it's sitting in your vehicle, and you'll go underneath a transmission line and you'll just start beeping, but they'll keep it zipped up. But otherwise, they try to wear it on the front of them, right on the, at their chest, or right around their waist on a belt clip. So as they're walking forward, it's, kind of getting their field of vision. That way, as they're walking and come up on maybe a downed conductor, if they don't see it, it'll warn them before they get too close. But that's really the only thing that the technicians have as far as the device is concerned. I mean, other than the regular PPE that you would expect, hard hat and vests and maybe safety gloves and boots and stuff like that.
Okay. Thanks, Josh. Any other questions for Josh?
You want me to go a little deeper into that, and then maybe some of the hardware and the ideas, Kieran?
Yes. I was going to invite you next to go in.
So we really all think that this is an area that could evolve quite a bit in the coming years. And we've done a little bit of testing. I think there's been some charge projects on augmented reality, and we did some very small tests with people wearing the glasses that would give them processed data as they're walking through a plant, so they kind of knew what was going on. And those have been real small. But I think in the personal protection area, there's a number of things with the smaller electronics that might become quite practical in the coming future. And one thing that I spoke with the others about is that when I started, I did various amount of nuclear work in college as well. And, we all started off wearing little film badges, right? So you'd wear them for a month, they'd take them to a lab, analyze it, then they'd come back and tell you if you had too much, right? Which was really not relevant information at that point, right? It's like, yep, you're going to be dead, right? So then at some point, personal rad monitors became something we all would wear at our nuclear facility. And it would tell you immediately what environment you were in, if you were within the parameters of what you had expected from the survey and to do your work and these things. So, I think with what Jason mentioned and, the other things, we're getting very, very close to where we could get some very good instruments doing that. So I think the challenge is around, making a polished product, right, is not the goal. It's sort of the proof of the possible. What are the ideas? And, can we show that, hey, this is intriguing enough that maybe to go forward? And I know OSU has some programs, and Ben, you might know more about that, but like if the students want to continue with an idea after the Make event, there's another program they can get into and then further develop that idea. And, who knows, something may come out of this event where, hey, that looks pretty intriguing. Maybe the temperature and humidity monitoring. So I think that's definitely a possibility. Do you want to talk hardware a little bit in some of our ideas? Is that a good place for that?
Yeah, that'd be great.
Okay, so again, in our challenge we wrote up, we gave some ideas on hardware. Now, those are not the only thing you can pick. You can choose to use something entirely different if you want. But these are some ideas that we had that we thought were pretty reachable for somebody fairly new to using this type of equipment. Arduinos are pretty simple to pick up if even if you haven't really used them before. Pretty simple to get one up and running. So the first device that we kind of thought about was this Nano 33, and it's in the Arduino family. And some of you may be familiar with like the Uno, which is sort of the basic model. So if you can program an Uno, you can program the Nano 33, and it's just a smaller board. It includes Bluetooth, so you can then write and interface that to a phone app. I've been able to get one to communicate to my phone, so the Bluetooth scanner sees it, but I've not went any further than that. I'm not much of a iPhone developer type person. And then the other thing nice with this Nano 33 is that it includes an accelerometer, a 9 degree of freedom accelerometer. So really all in that one chip without interfacing anything, you could do this sort of man down detector and have it communicate with the phone, and then maybe develop an app that then would text somebody if there's not been movement for so long. So that's, you know, without any interfacing with other chips, sort of that base project could be just that one device. Then if you want to use something with a little more power, I mean, feel free, you know, any of their Arduino family, a Raspberry Pi has Bluetooth built into it, a Pi 4, and it has tremendous capabilities with things for it. We also then had a pulse and oxygen sensor, which we thought was kind of an interesting chip to try. We're not sure about the physiology of if you did monitor somebody's pulse and skin O2, if that really would signal that you're entering a, you know, heat stroke condition or a low oxygen environment condition. But again, as a proof of concept, we thought that would be kind of an interesting one. So if anybody goes into the doctor's office and they clip the little device on your finger and then they read your O2 and stuff, well, if you can see right here, it's a little blurry, but this is the chip that's basically in that device at the doctor's office. So I believe that was included in the kit from OSU. I'm not sure about that part of it, but it's an I2C device. It's 3.3 volt. So we're really talking hardware now. So we made a point, all the chips were picked to be 3.3 volt. So you don't have to do any level shifting or anything like that. And they are I2C addressable, and there are different addresses. So you're not going to have to get on the board and solder the little jumpers around. So that simplified things a little bit as well. And I have, let's see here, if I can share a screen real quick, I'll show you that. That's right. Let's see here. Let's see, is that it? Oh, yes. Oh, there we go. So is that showing a little table of numbers?
Yep, I can see it.
Okay, so here's where I ran it just a few minutes ago, and here's where I put my finger on it. It was reading blood O2, giving a pulse rate, confidence number, and then I just had a cycle count going on just to know it was doing something. So pretty much that was the out-of-the-box example, and I just tweaked it a tiny bit. So, you know, I wanted to prove to myself it would work. And then the other one, out of the box example, is sort of the accelerometers, and it is quite smooth. I was pretty surprised at how well that works. So, you know, I think you'll find that's a pretty easy one also to achieve. Again, with the other chips, there's an environmental for temperature and humidity and pressure. So that could very easily be used to come up with like a heat exposure. And we have working rules in our safety and health standards that if you're working above a certain temperature and humidity level, you need to take mandatory breaks every so often. And, you know, or take a water break and things. So, you know, the device could certainly monitor something like that and then give the person a beep or an audible or light to say, hey, you know, you need to take your break so you can cool down and things. There's a UV sensor too, I believe. And, you know, with a lot of our outdoor folks, you know, skin exposure is a real issue. So a simple UV time exposure type calculation can be done that I think would be pretty valuable, because a lot of times you get out and you don't really realize you've been in the sun that long until you get the notice. And then finally, from a feedback, you know, you can do small little piezo beepers, a couple LED lights, or if you want to try to do a little bit fancier display, there was a little LCD display. And I've been tinkering around with that. There's something in the libraries is giving me some fits. So I don't know if I have the right library loaded or not, but if we get into that to the day of the event, just, you know, call us and I'll keep working here. I think I found a patch for it, but again, you know, these are meant to be more ideas and to stimulate your thinking, and then feel free to add in whatever chips or devices or just, you know, build together even a simulation of something. So like sound detection, we did not have a sound detector chip there. But if you have a small little microphone, it's pretty simple to include that. But you could also just simulate the sound level and then build some code in there to say, warn the employee of that event. So is that helpful for the kind of the overview on the hardware?
Yeah, definitely. I thought that was very helpful.
Okay. and again, I'm sure you've all used this kind of stuff before, and it can be very, very frustrating when something doesn't talk. And you got one bit out of place, and then all of a sudden you'll get it, and then you can kind of start running with all the different things to do with that data. So, and I'm really interested to see your Bluetooth, and if you have some phone apps come up, I really want to see that. So.
Perfect. Yeah, I was actually just about to ask, like, what sort of things in like that genre would you want to see in like a final product at this year's Make?
I mean, again, not prescriptive, just some ideas. But myself, I certainly like to have an app that tells me the thing is working right? Just it's alive and well. And then maybe that you could customize, maybe set some limits in there. Think of this as like if you're an employee working alone, right? If you were with somebody, the person you're working with kind of has your back, right? You look out for each other. And if you're really working alone, kind of part of my thinking is that the app or the device here is sort of supplementing that friend with you a little bit. It says, hey, do you realize you haven't stopped and had a break for the last 2 hours or something, and it's really hot today, and things like that.
Great. Thanks so much.
Great. Thank you, Wiley. That was great.
Talk a little bit more about that, Wiley. I mean, I think you're hitting the nail on the head. Getting this data isn't really anything that's particularly unique, right? It's
right.
What do you do with that data? How do you use that to present it to the user? Because any one of us can go buy these sensors and collect that data.
Right.
Then what do you do with it to make it meaningful to the end user? That's the more interesting part. And how do you solve some problem? And hopefully you got some of what our problems are. And I think Wiley, you did a really good job of hitting the big ones there of sun exposure and heart rate and temperature. And another one that I didn't talk about was a lot of times these guys having to go in enclosed spaces for the network systems were down in manholes and vaults. And so, they're taking with them, some sensors and things, but I don't think there's anything that monitors the person themselves. So they have an idea of what's in the environment around them and some equipment that'll kind of circulate the air, but nothing that really says, how's that person doing? It's more of just monitoring the environment around them. So it'd be kind of interesting to see. And I'll throw out an example of I remember when I did my senior design, that was all around industrial Internet of Things. And they wanted us to use LoRaWAN and trying to test that out in an industrial environment. And so we wanted to take some accelerometer sensor readings and some temperature sensor readings and a few other things. So what we ended up doing was building a .NET application that would store all that data, would collect it all back into a hub and store it in a database and run like a FFT, fast Fourier transform against it. So you could monitor a motor to see, what's the state of that motor, take a baseline, and then you could constantly monitor that and see, slight shifts in magnitude and of the frequency or this frequency itself to predict if a motor is going to fail ahead of time. And so just little things like that. That's not, again, collecting the data is somewhat like, okay, you got the data, just about anybody can do that, but doing something meaningful and trying to be creative with it, be really cool to see you guys do.
Yeah. And, adding to that, that's exactly right. Because, if you get frustrated and some chip doesn't work right, or you wish you had some other chip that isn't there, just simulate the data, put a little potentiometer there, and then you can run with your idea. Like, can you really monitor, say, explosive gas levels? Like we do not have gas sensor chips here, but you could certainly make a little pot that you could vary between your concentration levels, and then have the device look at lower and upper explosion limits and maybe generate an alarm there. But then you could sort of start thinking again about keeping that worker safe and keeping him very aware of his environment and the risks in that environment. I think that's the main goal here.
Awesome. Awesome. Thank you. Thank you, Wiley and Josh. That was great. Any other questions?
Yeah, hi. I had a question. In
Sure.
the documentation for the project, it said that we might be able to get, it said, I think you have a limited number of hard hats that we could possibly get. I don't know if anyone.
Yes, we can check. One of the other guys, he's not on the call right now, but he did have a number of them. And our thought with that was, you know, if you want to build the device that clips onto the hard hat or something, you know, just like you see where we put flashlights and other pieces of equipment. And that was just sort of the idea to tie it up. But we'll need to check with OSU about the way to get that distributed. Have you picked that? What's the logistics for the kits and the pickup and that type of thing?
They've been doing kit pickups today, tomorrow, and Friday.
Okay.
I'm going tomorrow, so at about 3. I don't know if
Okay.
that might be a tight timeline to get it.
Yeah.
But they're not that expensive on Amazon, and we would want to modify it maybe so it'd have like a mounting hole or something in it. And if we don't want to like borrow one and modify.
Oh, no. It would be given to you. We wouldn't want it back. So,
yeah,
I can tell you from an OSHA standpoint, though, they're very picky about modifying hard hats. So,
yeah, at least for the sake of
it. But for this, it'd be fun. Yeah.
For the sake of a hackathon, we'll look past that. But
I think Jason would agree. You're not supposed to drill holes in your hard hat and bolt things to it. So,
sure. Yeah,
I'll tell you, let me check. And then Ben, if I'm able to get one, you know, is there someplace we could just drop off a few on campus or?
Yeah, you'd be able to drop that off at Caldwell at our OHIO office. I can give you more details about that after the call if you'd like.
Okay, I'll tell you, if you don't mind, touch base with me in the morning, and then if I forget, it'll remind me, and maybe I'll have an answer. But I'll try to send an email or two right now to see if I can, you know, Matt can grab a few. So
sounds good.
Thank you. Thank you. I think we have a question on the chat, and the question is for Jason. I'll read out the question, Jason. I believe you spoke about safety in industrial and commercial setting. How often do safety policies and standards ever change beyond just an operational or field incident, or from a new scientific or statistical data perspective?
Good question. I'm trying to analyze the different pieces of that.
Well, I'll take a little bit of that. So, I mean, from a maybe a little bit different angle from the like we have a standards organization or group at AEP for distribution, which is the side again I work on. And so they're constantly getting feedback from the field folks and from you know, wider industry, and a lot of like we're part of EPRI. I can't remember what that stands for off the top of my head. And so they're constantly looking at, you know, safer ways of doing things and collaborating across, you know, multiple utilities to come up with best practices. And then, you know, the standards organization's constantly reviewing all that information, and they're always putting out new standards and maybe changing out, you know, vendors from one piece of equipment to the next. So a little bit different twist to that. It's not directly, you know, maybe safety organization related, but I mean, that's stuff that it's constantly changing and being looked at. The industry is constantly moving.
Yeah, and EPRI is Electric Power Research Institute, by the way. And and what Josh said is spot on. And most of the things that we change, we're changing because it's best practices and it's, you know, the most up-to-date information to protect our employees. If we waited on OSHA to change, you know, that would be a long time, because OSHA, that you know, that is truly the regulatory force behind safety and health standards, you know, they have to go jump through so many hoops to change or develop a new standard that it's a very, very slow process.
Thank you. Thank you, Jason and Josh. Thank you, Martha, for your question. Any other questions? Okay. I also wanted to quickly touch base about the prices. So AEP will be offering $200 Amazon gift card for the winning team. And we will also be, we do have a virtual table out there. So we will have representatives from our company there. Come do meet us. We are also giving out, some gift cards, Amazon $5 gift cards as swag items. So do come to our virtual stall and, engage in discussions. We'll be happy to answer any questions as well as, pass over the swag items and things like that.
I just had a quick question on that. The website from OHIO might be incorrect. They say they're doing 4 $200 gift cards. Is it one per team or one per person?
Yeah, one per person.
Okay, so there's
yeah. Yeah. Okay. Any other questions? If not, I'll give it back to Ben.
Well, great. Thank you guys all so much for being here. I thought this talk was incredible. It's like a lot that we can learn from and a lot that I had no idea about. So really enjoyed it. Thank you guys.
Thank you. Thank you. And good luck.